You send a metal part design to a supplier. They come back with two quotes, one for stamping and one for die casting. Now prices are completely different, lead times are different, and you have no idea which one actually works for your part. So here's how to decide. 5 questions and it takes 2 minutes. At Haizol, we see stamping and die casting inquiries every day from companies sourcing custom metal parts through our marketplace. Now, one of the most common questions is, my supplier offered both stamping and die casting. Which one should I pick? And the answer always comes back to 3 things: geometry, material, and volume. What is metal stamping? Metal stamping takes flat sheet metal and forms it using high tonnage presses. Progressive die stamping is the most efficient version. A metal coil feeds through a die with multiple stations. One press stroke produces a finished part. Now, this is best for flat or shallow parts that are 0.5 to 6 millimeters in thickness, high volume production, steel, stainless steel, aluminium, copper, and brass. What it can't do is internal cavities or complex 3D geometry or thick solid sections. So what is die casting? Die casting injects molten metal into a steel mold under high pressure. That's best for complex 3D shapes with ribs, bosses, and mounting features or internal cavities, high volume production in aluminium, zinc, or magnesium. Generally, it cannot do ferrous metals. Steel melting point is too high for standard die casting models. Also, it cannot do consistent, very thin walls like stamping or economical low volume production. The 5-question framework. Question 1, geometry, flat or shallow with bends. Stamping, complex 3D with cavities and ribs. Die casting. Question 2, internal cavities needed. If yes, that means die casting only. Stamping cannot reach hollow sections. Question 3, material. Is it steel or stainless? If so, stamping only. If it's aluminium, zinc, or magnesium, then either process based on geometry. Question 4, tolerances. They need to be tighter than plus or minus 0.1 millimeter. Well, stamping can reach that on suitable features without secondary ops. Die casting standard is plus or minus 0.2 millimeters down to plus or minus 0.05 millimeters with post machining. Question 5, tooling budget. Stamping tooling costs less than die casting tooling. So choose stamping when you have flat geometry or ferrous metals or tighter tolerances or lower tooling budgets, and choose die casting when you have complex 3D or internal cavities, non-ferrous metals, and you're willing to invest in higher tooling costs. Common mistakes. Mistake 1, stamping complex 3D geometry. Electronics housing with internal ribs and screw bosses quoted as stamping. Parts arrive with no internal features and redesign or secondary assembly is required. It should have been die cast. Mistake 2, die casting simple flat brackets. L-shaped brackets with 2 bends and 4 holes quoted as die casting. Higher tooling, higher per part cost, longer lead time. All for capabilities you do not need. Should have been stamped. Mistake 3, missing the hybrid option. When most geometry is flat, but one feature is complex, stamp the base, die cast the complex component, and then assemble. And that saves up to 15 to 30% versus full die casting. And most buyers never explore this. Material differences. Stamping, steel, stainless, aluminium, copper, brass, anything available in sheet form. For die casting, we're talking aluminium, zinc, magnesium alloys. You cannot die cast steel or stainless because the melting point is too high. If your part requires steel, then stamping or CNC. If aluminium or zinc is acceptable and you need complex 3D, well, then it's die casting. 5 questions. Geometry, internal cavities, material, tolerances, and tooling budget. Answer those and you will know whether stamping or die casting fits your part. Screenshot the framework at 2 minutes and 45 seconds and drop any questions you have in the comments.